that's the thing about LabVIEW. There's 6 different ways to do the same thing. And so um, unless it really matters most of the time, whether you do it one way or the other, doesn't matter
Yeah.
significantly.
Welcome to the LabVIEW experiment. I am your host, Sam Taggart from SAS Workshops. In my 15 years of working with and training developers, I've had the opportunity to conduct a lot of experiments. Over here, we believe in embracing failure as the essential learning experience that it is. And what better way to learn than from other people's mistakes? In this podcast, I talk to industry experts, colleagues, and friends about their failures and how they have turned them into future successes. I am here today with Katya Prince. Some of you may know Katya. She's been around for quite a while and attends a lot of the events, CLA summits and NI Week and all of those things. And GDevCon NA, you presented at GDevCon NA last year, right? With the vision
Uh,
thing?
Year before,
Year before, okay.
but
Yeah, I get those
yeah,
confused. They all kind of blend together.
true, true.
Yeah, so you've been around for quite a while and done a lot of projects. Do you want to, maybe we should start talking about some of the different projects that you've done, because I know you've done quite a variety of things.
Right. Yeah, I have done things from working with universities, doing biotech, doing you name it, I've done it type of thing. Everything from life cycle testers or um, production line testing, process automation, um, all the different things that LabVIEW can do, I've done in one capacity or another.
Now, when you go through this wide variety of projects, does your approach kind of change depending on the project, or do you have like a standard approach that you try to fit into each project, or how does that work?
Um, there are a lot of similar things that I use from project to project, but I try to look at the unique challenges of a given project. A production line tester is going to have different requirements, have to talk to equipment versus maybe a lab test, which only has to do things 3 times a day. So the architecture might be a little bit different.
Yeah, I
But
think about like uptime requirements and maybe like the cost of failure in each of those situations, right? Like lab tests, sometimes if it fails, oh, big deal, versus like
right,
destructive versus non-destructive test. I've worked on some where it's a destructive test. In that case, you really want to get it right. Versus
true, true.
non-destructive is okay, something happens, you rerun the test, no big deal. You don't lose anything.
Exactly, exactly. And things like a production line tester, if it goes down, you've got millions of dollars on the line and you've got everybody breathing down your neck to try and get it up and running again. So yeah, so there's definitely different challenges there.
Yeah, performance is probably also important too for end of production line tester, depending on how quick, if it's the bottleneck, right? I guess if it's not the,
Right,
maybe not as big a deal, but
right.
because yeah.
They always want to shave as much time as they can or put in multiple paths if that becomes a bottleneck. Yeah.
Well, I did a production line testing thing for these climbing auto belay devices, and they would take like, they only produce like a dozen a day or something. So it wasn't like
Hmm.
the test took, if the test took 15 minutes, nobody cared when they're only making a dozen a day.
Right. That's true. That's very true. And again, depends on depends
Volume.
on everything.
Yeah, that's the beauty of being a consultant and hiring a consultant. You kind of see everything, and then you can tailor things specifically. I think, people want this like cookie cutter, like, oh, I just use DQMH on everything. And, yeah, it's
Yeah.
a really good hammer, but not everything's a nail. And so sometimes it helps to be able to be a little flexible.
Yeah. I also think I this has been talked to a million different times, but knowing who your target is going to be as well. So is this something that I'm going to be solely responsible for, or I'm going to have to pass this off to somebody else? And that will also dictate how I write stuff. I might make the code dirt simple, and maybe not as sophisticated if I know that a junior engineer is going to take over later. So those are the other things that sort of in the back of my head.
Yeah, I definitely think about that too. And then I also think about like, you know, trying to avoid overcomplicating things, I think sometimes because we get
Yeah,
excited and we're like, oh, we could add this feature and that feature and that feature. And like trying to very carefully communicate with the client and figure out exactly what they want and need. And
right.
instead of just like going off and building this big gold plated thing, sometimes people,
Yeah, yeah. Understanding what the client wants, that's sometimes the hardest thing. I had a project early on in my career, super early, And I was like, oh, we're going to have a password and the user's going to enter this. And won't that be cool? And at the time, this was years and years ago, where the operators were afraid of the computer. And so the idea of actually typing in a name and a password was way beyond the type of things that they wanted. And so that was something that, while I thought it was slick and it was going to be great, just failed. And I had to pull all that code out. And it was just a go, no go. They didn't want to have any interaction with the PC if they could. So that's definitely got to you've got to listen to your end user.
So how often do you find that you're starting a project from scratch versus inheriting somebody else's code?
Um, I'd say 3/4 is either a rewrite of something I've already written or something I write from the ground up, and maybe a quarter of the projects are other people's stuff. Lately, I've been working actually a lot on, we have this piece of code and we just need this one thing changed. And so I'll go in and I'll do that one change, but I don't touch the code because the rest of it works. And
Yeah.
that seems to be coming up a lot lately. So,
Is it ever as simple as they tell you it is?
yeah,
Oh,
yeah.
yeah, it is.
Sometimes it's
Okay.
actually simpler. So, and
Good.
actually, it's only simpler because I know, like, oh, you have the wrong COM port, that kind of thing.
Oh, those
So,
type of problems. Okay.
yeah.
Because usually, like,
But
I encounter
mhm,
stuff like, oh, just add a dialogue box here. Then you're like that sounds,
uh,
but like to actually do it requires a lot more understanding of the program. And
this is true. This is true. But it's all fun.
yeah, so have you run into any challenging situations with dealing with other people's code, or is it mostly the simple things?
Oh, yeah. I've dealt with some code um, that's just crazy. Like somebody had auto grow, and then they were sort of novice users, and
Oh,
so the the block diagram just getting bigger and bigger and bigger and bigger, and just finding things was a task, to try and clean up that code. It was crazy. It was easily, I don't even know, 10 by 10. It was that crazy, just because they were dropping things and then everything got bigger, and then they dropped something, it'd get bigger. So
do you have any tips or tricks for dealing with that type of code? Or
go in small, and just chisel at it, create sub VIs where you can, and just
yeah.
you just that's the only thing you can do if you're not going to rewrite the whole thing.
So start fixing the little things, and because that's what I try to do. Like I go in and like, okay, this VI doesn't have an icon. Let's change that. This thing's named poorly. Let's change the name and try to do some of the thing. There's certain things that you can do that are not going to break things generally, right? Like you said,
Right,
creating sub VIs. Generally, you can create a sub VI, and 99% of the time, that's not going to break everything.
right, right. I go and I look for duplicate code, see that all the time.
Mhm.
Duplicate code, okay, we can easily make that a sub VI and sort of clean up the block diagram.
Now,
So
how do you verify that you haven't broken their code while you're doing these things? Are you just very, very careful?
very, very careful. And um, you're assuming that the code was working to begin with. So
Well, that is, yeah, that is.
so if they give me a list of this is what it's got to do, then I can hopefully go in and test it and not break it.
I was gonna say, do you find that they usually have tests, or do you put some kind of tests around it, or are you just
Depends on the user. Usually, if it's that far gone, they don't have tests, because if
yeah?
it's that poorly written to begin with, there are no tests. So the only thing you can do is just test it. Does it run? Tweak it a little bit. Does it still run? Does it still run? Does it still run? That kind of stuff.
Yeah. Well, what I've started doing is in cases like that is like I tell them, I'm like, you have to have a test plan and come up with a test plan.
Oh,
And
sure.
generally it's like a whole system test. It's like, okay, we've got multiple testers. I'll apply my fixes to one. You run the same piece through both, or
Right.
several pieces, and some that are defective, and compare the reports. And if the reports look good, then we're okay.
Yep. That's a
That's like
good way to do it.
the best I've figured out. I mean, I've got some tools for like testing existing code, but it's generally messy and hard. And like usually because they didn't write the code thinking that they were going to test it, it's really hard to test
Hmm.
for those reasons because they're kind of mixing lots of stuff together and like, you get the
Yes,
nested things, but then in the middle, it's like doing something weird, interacting with the hardware is like down in the middle of the nesting. And so you can't, the logic is not really separated out from all the
agree,
other hard
agree.
to test stuff.
Hmm.
So, yeah, that would be my one plea for people to like, even if you're not going the full test driven design route or whatever, at least think about how you're going to test some of this stuff. At least be like,
Yeah,
yeah,
yeah, yep.
yeah. So are most of the projects you work on smaller or on the larger side or somewhere in the middle?
Somewhere in the middle. I'd say the majority are like my bigger projects are probably 3 to 4 weeks. Most of them. Occasionally I'll get like a 2 or 3 day thing. And then occasionally I'll get a 6 month or a year long project. A lot of times uh, I might do a 4 week project and then come back next year when they want to make changes to it or want to change it for a different production line or something like that. So there's a lot of repeat business. I'll say I've got a lot of repeat business. I'd say easily a quarter every year is a repeat customer.
So, being a business owner myself, do you have trouble keeping your pipeline full, or is it generally pretty easy to keep things full?
The well, it's a small business. It has its ups and downs, and um, it's feast or famine type of thing. These days, I don't have a problem. I've been doing it long enough that now that again, between repeat business, referrals, and then occasionally stuff from NI, occasionally stuff coming in from my website, um, but it's mostly repeat business these days.
In repeat business, then are they bringing you in on new projects, or are they mostly like asking you to like update stuff that you've done before?
Um, I'd say it's more new projects than updates, but even then, um, again, customer to customer, it changes.
Yeah, I know. I found like several companies I've done work for them, and basically they've got like one LabVIEW project. They have nobody who does LabVIEW, and so you do the project for them. And then if you do a
Right,
good job and there's no bugs,
right.
then there's nothing to come back to. And so that's one of the things that I've noticed. But yeah, it's
Mhm.
interesting. I have had some call me back occasionally, be like, "Hey, can you add this thing or update this thing?" And that's useful.
Yeah, I don't. The the come back and change things are usually because they've done something
Yep.
like they've changed a communication protocol on some instrument, or they've changed the instrument that they want to use, and so that's more the stuff I come in to do repeat on the same code.
Yeah.
More often than not, it's like we have a new tester that we want built. Can you come in and do that? That kind of stuff.
Yeah. Well, often I've noticed it depends on the thing, but when they build a new tester, they often try to like redesign some of the hardware and stuff and like improve things.
Hmm.
So yeah, that definitely opens up some opportunities. That usually requires updating the software as well. So
Yeah, to some extent, sure.
yeah. Um, so you mentioned earlier you mentioned something about rewriting codes. Do you have any guidance on like balancing? Like when do you refactor something? When do you inherit something you're just like, this is too far gone, we should just start over?
Yeah, that is such a tricky one, especially because from the manager's point of view, well, we've already written this. Why would we rewrite it? And that's the hardest sell. Um, and I found that is there anything that I've had to like burn to the ground? I don't think there's anything that I've gotten where I've had to completely burn it to the ground. Um, so for me, it's worked out that rewriting, sorry, not rewriting from the ground up, but modifying the existing
Yeah.
works better. But I think that's probably going to be the bane of our existence of convincing the managers or the higher ups to spend more money.
Yeah, as I've gotten
So,
older, I've gotten lean more towards the refactoring as opposed to rewriting. Like especially like if the thing works and they
mhm,
just want a small change, it's really hard to justify like, hey, let's throw all this away. And also there's like a
exactly,
bunch of risks
exactly.
that the one place though I have definitely, and I don't know if you've encountered this, but I have people call me up sometimes like, we hired this guy for 6 months, he wrote us this code, it doesn't work. Here you go. Can you make
Right.
it work? And in those cases, I'm always like, nope. Well, I don't know.
Yeah,
Depends on how close it is, but usually I'm like, nope. I'm like, we're gonna start over and do it right.
right, right. Yeah, I agree with you on that one. So,
Yeah, because I mean, you're preserving the value by doing the refactoring, but if it never worked, there really was no value. At that point, it's just a sunk cost.
sure, exactly,
So,
exactly.
yeah.
I agree.
So you mentioned at one point doing some work with the FDA and
Yeah.
about regulations. You want to talk
Hmm.
about that?
Sure. Yeah, I've been running into it a lot lately of getting LabVIEW into biomedical devices and having to be much more stringent in the way I write code, in keeping track of all the extra little add-on packages that we use, and then more rigorous testing and documentation of everything. So um, I've been finding, especially lately, that obviously all the unit testings are critical, and VI analyzer and that kind of stuff. Been playing a lot around with that quite a bit, and it's just like a next level of, you write your code, but then you really you can't be sloppy at all. So it's been a challenge to not be lazy and not just say, oh, I'm just going to reuse this and I'm going to change this now. It's like, nope, you can't, because we've got to run it through tests. And once it's in the package, you can't change it at all, anything about it at all. So um, it's been interesting to try and get through all the FDA requirements and stuff.
So are most of those requirements around like reliability of the devices and like not causing harm, or are they more related to security or both? Or
It's both. Actually, recently it seems like the cybersecurity stuff has become paramount. But it's the do no harm, and then it's and a lot of the stuff that I do, it's not even so much the do no harm part, because you can't really use LabVIEW stuff for anything sort of I want to say mission critical. That's not the exact right word, but it's that it has to do what you say it does, and that's more important. And you have to document that it says, that you're doing what it says it does. And that whole tree of going from requirements down to the actual code is pretty rigorous and time consuming. That's for sure.
so we're talking like traceability matrix type stuff,
Yeah.
right? Like this is a
Hmm.
requirement. How do you meet this? Oh, here's a piece of code. Do
Exactly.
does it usually point to a piece of code, or would you point to like a test somewhere that says this actually tests that? Or is it both? Or
It's both. I never got requirements gateway to work, but apparently with requirements gateway, you basically put a tag bookmark in your code, and that bookmark can point back to the traceability matrix, which then traces all the way up to your original requirement. Because you can have multiple VIs that take care of the same requirement, or are necessary for the same requirement.
yeah.
So it can get pretty messy pretty quickly.
I imagine there's an opportunity there because I haven't heard a whole lot about requirements gateway anymore. I thought that was kind of like maybe
Yeah, I don't know.
unofficially discontinued. But LabVIEW does have the bookmark manager and
Right.
it's plugin. So I imagine an ambitious person could probably write their own thing to go through and do some of that.
Sure, sure. Yeah, I've done that before. You can go in and you can, you know, gather up all of your bookmarks, but then you have to worry about how that then ties into your other documents. And so you would have to put a whole structure in place to tie it into the requirements, I would guess, but I haven't done it yet. Maybe I'll do that this year. I'll have to do that this year. We'll see.
Yeah. So you mentioned we talked a little bit about security. You mentioned about like
Mhm.
detailing like what's included. Do you have to do these SBOMs, the software bill of materials things that people are talking about?
Sort of. I basically, at least in the one project I'm thinking about, I'm doing more of the coding and letting other people take care of the paperwork so much. So um, they're more concerned with um, uh, basically an SBOM with all the stuff in it. So we need to know all the LabVIEW stuff, and then also not just the LabVIEW stuff, but anything I get off of VI package manager, any of the add-ons, anything like that. I have to list it all out and say, well, this wasn't built by NI, it was built by, who knows who,
Yeah.
and or so you have to compartmentalize all that stuff. And again, it just comes down to documentation more than anything else.
Do you ever have to
So,
dive in deeper into the NI stuff? Like do you just tell them like I got this version of LabVIEW, or do you go in and like this uses this version of OpenSSL and this version of blah blah blah? Because I know like NI pulls in a bunch of has its own
Right.
season software bill of materials kind of stuff.
Haven't gotten into that far into the weeds, so to speak. Ask me in 3 months, I may have a different answer. Um, but for now, I just go, at this point, I just worry about what VIs I'm using and not all of the rest of the stuff necessarily, if that
Okay.
makes sense.
Yeah, yeah.
So
So, how does this level of rigor, I guess, compare to like most projects that you do? Like, do like the average customer who's not FDA, do they even care about documentation? Do they just like make it work? And
yeah, they're for the most part they're make it work. Create us a little how-to document, and that's about it. They don't care about what's happening under the hood, as
yeah,
long as it runs, as long as it's bug-free or mostly bug-free. They don't care what it looks like under the hood, you know.
and I assume most of the code that when you inherit it is also not very well documented.
Oh, yes, yes. That's like the first, that's almost what I do at the very beginning, even before I start pulling code apart, is I'll go in and I'll actually start documenting, okay, this is what I think this does. This is what I think this does. If nothing else, just to get my head in
Yeah,
tune with the way they've written
I
things.
think that there's a word for that, and I think it might be called like opportunistic refactoring or refactoring to learn, where you just take the code and all you do is you just do like as you're reading it, you just start like renaming stuff and putting comments in and moving stuff around and cleaning it up and
Yeah,
block diagram clean up here and there, and it just kind of really helps to understand what's going on.
for sure, for sure.
The
Yeah.
one thing that I would urge everybody listening, and I really wish projects came with just a README that just said, here's how you start the project and get it set up. And here, here's the main VI, because that's not
Hmm.
often obvious. Here's the VIPM package to install. Here's what
Right,
version of LabVIEW it's written in. Just like that, it doesn't even have to be like super huge, but like just like imagine if you're writing a project and you had to onboard
yeah.
somebody, what would you tell them to get it up and running on their computer?
Right. Well, yeah, I've had to do that actually for the I've done that for some of my projects, and I've also done that. Uh, I guess it's just an installation guide. It's sort
Yeah.
of become now sort of my standard practice that at the end of the project, I build sort of a quick start, like, okay, you want to install this on a new PC. This is what you're going to need to do.
Yeah,
Because
yeah.
that's the other thing I've been running into a fair amount lately is like, hey, we our hard drive died. What do I need to do to get this up and running again?
Yeah,
And you just forget 6 months down the line, you forget.
yeah, so I think there's actually two guides that are needed to your point. One is a for devs, here's how you set up the development environment. Here's what
Hmm.
you know. Just like the basics, like high level, right? Just enough to get it up and running and be able to click run and then how do you build it, right? Like
Right,
those things. And then for users, it is okay, how do you install some new PC? What other packages does it need? Does it need registry
right,
key, environment variables, folder structure, right? Like all those
right,
things. Yeah.
right.
Yeah, pretty much anytime I touch a project, if it doesn't have that, by the time I leave, it does
Oh, very good, very
because I'm
good.
envisioning your situation where they call me back to go do it again, work on it again in like a year, and I'm like, I'm not going to
Yeah,
remember all this, and like,
yeah. Yeah, the only nice thing that I've set up on my system too is using virtual machines. I'm sure everybody uses
yeah,
them. I hope everybody uses them, but that also helps out a lot because I can, once I know what version a particular project's in, I can go to that virtual machine, and there's a good chance that the code is still there from the last time I worked on it. So,
yeah,
um,
yeah. So you just archive those then at the end of a project.
uh, no, I don't have it on a per project basis. I have it on a per LabVIEW basis, the
Okay,
LabVIEW version. So I have a
yeah,
LabVIEW, whatever, all the way back to XP with LabVIEW 7.1 if we really needed it. So, um,
yeah. I
but
used to do it on per project, and then I ended up with a lot, and I realized that like a bunch of them would use the same version. I'm like, I'll just do per version unless I need something special, and occasionally I do,
right.
but
Right. Yeah, there were a couple of clients I've had that had a real specific set of other add-ons that you needed that were
mm,
just weren't needed in general and just got clogged up. And so yeah, but for the most part, everybody uses the same LabVIEW 2019
yeah. Even
project.
even with the virtual machines, though, I still like having that developer setup doc just because I kind of view the virtual
Oh,
machine.
sure.
Because there's been several times that I've just like had to throw them away for whatever reason, and I start over from scratch. And sometimes it's just
Hmm.
easier to just like spin up the latest Windows ISO and reinstall LabVIEW than trying to untangle some problem.
This is true. You're right. You're right.
And also, too, I think like, okay, if somebody else inherits this, they're not going to have the virtual machine already set up. So
Yeah, and also a lot of times I have to take the code and run it on the customer's PC. So
yeah,
you're right.
exactly.
Having like that would be helpful. Mhm.
Yeah, I think that's I had a discussion with somebody where they were talking about like agile or they use the word agile, but like basically their point was something like it's not about just solving the problem, it's about solving the problem today and tomorrow and the next day. And so setting yourself up in the future to make it easier to solve problems in the future, I think is a really useful.
Hmm.
And
Yeah.
and it doesn't take that much time. So I highly encourage people, if you're not doing that, to start thinking along those lines. What does Fab say? Be kind to your future self or something.
Yeah. Yeah, definitely. Because you just like adding comments, you're not going to remember in 6 months exactly how the system was set up. So
Yeah. Something else I wanted to talk about. You had mentioned that you learn well from watching and coding with other people. Have you done
sure.
do a lot of pair programming? How does that work?
Um, well, so now I'm on the other side. So I have done paired programming with more junior people. But when I was in the beginning, all it was looking over somebody's shoulder and watching them code and then like, hey, what did you just do? That kind of stuff. And then also just looking through their code in general, searching the different palettes. How did they do that particular algorithm? And hopefully they left comments, but if they didn't, try to figure out the LabVIEW code and see if it was more efficient than whatever I was doing. So,
So that
yeah.
brings up an interesting point.
Mhm.
Can you think of a time where you inherited some legacy code and you actually learned something from looking at the legacy code? You're like, oh, you see something, you're like,
Oh,
I didn't
yeah.
do that.
Yeah. Yeah. There was somebody, there were two things that they did that was really slick. Um, so if you have an enum and you want to go through all of the cases in a for loop for whatever reason,
Yeah.
you can cast a number to the enum, the zero case, subtract one, which gives you the max, and then cast it to an integer, and then you basically have, and then I think you have to add one. And now you have the number of enums that you have to run through if you have to run through all of them for whatever reason. That was something I picked up from somebody else's code. And then another slick thing was when you get arrays and you want to add something to, you want to increment, you want to add a new value to it. So you say you have however many you have, rather than doing the build and then decrease the size, build, decrease the size, you push the value into the first element and then rotate the whole array. And that basically is an in place, that's completely in place. You don't resize arrays or anything like that. And it's much more efficient when you have these long-term tests that are running for days and you don't want to be doing this build and truncate, build and truncate, build and truncate. So those are two things that I picked up from other people's code that
Wow.
is really
There you
slick.
go. Cool.
So yeah. So yeah, and just like I said, I'm picking up stuff from everybody every time I look at somebody's code for sure.
Yeah, it's always interesting. Yeah, looking at other people's code, it's challenging. And I feel like, and maybe do you ever get the like, I feel like anything that I didn't write, it's always like I have a negative reaction to it at first. Usually, not always, but I often get a negative reaction like, why would you do it that way? Right? Because
Yeah,
I'm, I'm I'm looking at the problem and I've got my own idea of the solution and they did something different. I'm like, wow. Like sometimes it matches my thought process. I'm like, okay, yeah, this makes sense. But
right.
oftentimes, why? And I really have to go back to
Mhm.
like, what do they call it? The retrospective prime directive of like, assume everybody is doing the best they can and trying to do a good job. And like, if they didn't, maybe they didn't know this feature existed, or maybe it
Right.
didn't when they wrote it or something like that. And yeah.
Yeah, yeah. I try to. when I see something that I don't understand, I try to assume that it's being done more efficiently than what I'm doing and
Uh,
try and figure it out and then make that decision.
uh,
You know, no, it's not more efficient. But
yeah.
that's the thing about LabVIEW. There's six different ways to do the same thing. And so, um, unless it really matters, most of the time, whether you do it one way or the other, doesn't matter
Yeah.
significantly.
Yeah, I don't
So,
know. It's always interesting when you're looking at the code for the first time and somebody else is standing over your shoulder because you really got to like watch what you say.
oh,
I often
yes.
say, oh, that's interesting. Or, oh, that's
Hmm.
not the way I would have done it. But I try not to like, yeah, it's hard, right? Because, criticizing people's code, sometimes people take it very personally. And so like, that's also, even when the criticism is legitimate, you still have to like couch it, correct.
Yeah.
But there's a more efficient way to do this or something, as opposed to, oh, this code is crap or whatever. I don't know. I don't know.
Yeah, yeah, that's true. Diplomacy, I think they call
Well,
it.
how do you
So,
break it to somebody? Like, say you've got a manager, they had somebody write code, that person left, and the code is just like junk. And like, like maybe it works, but you're just like, man, this really needs like rewritten or redone. Like, how do you break it to a manager or somebody who's not maybe not a coder, right? And doesn't get it
right.
without coming
That's
off
a
as like, because everybody from the outside always comes, oh, it's junk, we should rewrite it. Like, how do you convince people that like maybe this needs rewritten or maybe it needs some extra work?
it sort of depends on whether it's working or not. If it's working, I don't worry about it. Like it
Yeah,
may be
just
junk.
change what you need to change and band.
Exactly.
Yeah.
Now, if it's not working, then I can go in and I can say, okay, this is the reason why it's not working. And at that point, say, um, then make the judgment call on whether you have to rewrite it or just refactor it and stuff. But um, yeah, again, if it's working, I try not to worry about it too much. Um, you hurt people's feelings and they don't want to pay to
Yeah,
have
yeah.
it rewritten.
So
So
yeah, I guess another question is if you encounter something that's working and say you've added some duct tape and stuff, at what point do you say, I've added enough duct tape and band-aids? We really need to like make some large
yeah,
architectural changes, right? Because often the duct tape and band-aids, like you're solving the symptom, but you're like, man, if this architecture changed just a little bit,
yeah,
it'd be better, but
yeah,
like you don't want to touch it. And then you're like, do you reach a point where you're like, I really need to touch this bigger part of the program?
yeah. Again, try and take it in baby steps. Try and take the smallest possible thing that you could change that would make your life a lot easier. It might be something like taking a sequence structure and making it into a while loop with case structures or something like that. It could be something like that that's again just a small piece that makes your life easier if you then have to change the order of stuff. But
Yeah.
you know, um, I think this is an age-old question that you're asking that every programmer has to sort of figure out what their threshold is and make changes as when it gets to be too painful. So
Yeah.
yeah,
Another thing that you had mentioned is that you've been playing around with the MGI panel manager
yeah.
and some configuration GUIs. You want to talk about
Hmm.
that a little bit?
Yeah, sure. That sort of goes back to sort of the idea of the paired programming and stuff and finding toolkits that seem to work really well. And that was one that I ran across that I've been working with, I guess, in the last project to basically create that a good configuration editor for a particular project that they made it. It was it was a lot of work to get it set up, but now that it's set up, I think adding new it's a system that uses a lot of hardware, and they want to be able to configure all of the hardware. So setting that up initially was a huge learning curve for me. But now that it's in place, to create a new instrument with a new configuration, it just sort of it'll just be a not a copy and paste, but basically will be much easier if when that happens. So again, just something cool that I've picked up I picked up and started working with lately.
So
Um,
correct me if I'm wrong, but in my opinion, is that configuration is one of those things that like nobody really talks about, but I feel like we all struggle with it. We all do it
Yeah.
differently, and different projects have different requirements. And I've
Hmm.
always wanted to like write one configuration dialog box I could just use for everything, and it never
Right.
seems to work that.
Right.
I haven't quite figured that out yet.
Right. Well, I think what came down to this particular project and the way it worked, and it was something that I'd never really thought of before for whatever reason, because I didn't, was if you if you have, for example, an instrument that has a configuration, the configuration is a class. And so now the interface is just you basically pull that in and out, and the interface becomes just a VI of that class.
Mhm.
So they basically pop in and out without worrying about things like, um, oh, this one uses a COM port, and this one uses
Yeah.
has a network, and this one is this, and this one is that, because all of that is contained within the configuration class. And you don't get the conflict of the different values and having to keep track of all the different values for all your different machines or all your different instruments.
Yeah.
So,
Yeah. It's a couple of the issues I've found with configuration. One is range checking on various values. That's always interesting because people have different ideas about that. Like you can't just have like numeric. You need to have like on the config dialog box, you have to be able to limit sometimes. That was one problem. The other problem was distributing the okay, so you've got your configuration, but what do you pass to each module? Do you pass in each a cluster? Do you pass like how do you do that? And how do you avoid coupling things too closely if you're not careful?
well, that's where the idea of using a
The class.
class for the configuration. So your instrument has a config class in it. So you
Right.
don't have in your instrument your configuration data. You
Yeah,
have
yeah,
config
class.
class.
Yeah, and it's kind of abstract. Yeah.
And so everybody passes that config class, but their particular, instantiation of it, whatever you want to call it,
Yeah.
is unique, and you don't
Yeah.
have to worry about that clashing. Yeah. Yep.
All right. So one thing I like to ask everyone is, can you tell me
Hmm.
about an experiment that you tried that didn't turn out the way you thought it would, and what did you learn?
Yes, this was a big question. And it's not LabVIEW related, particularly. So early on, 2 or 3 years after I started doing consulting, I decided that I had to grow my company and I was going to merge with another company. And so the big experiment was this merging of myself and this other alliance partner. And it did not work. Did not work at all. It Nobody's fault, just didn't work. And so after about a year or so, we parted ways, and we're both happier for it, I suppose. And the main thing that I learned from that was that at that time it was all about like, well, you got to grow your company, you got to be bigger. Everybody was like, bigger is better. That's the way you got to go. And um, no, no, not necessarily. That was however many years ago, 20 years ago or whatever. And I'm doing what I want to be doing, how I want to be doing it, not based on, the sort of the peer pressure of, well, if you have a business, you must make it bigger. So that was what I learned.
Yeah,
Do it
and I
my own way.
definitely drove that for a while with all its partner program rankings and stuff.
Hmm.
So, yeah, I mean, I think for me, it's about doing what you want to do. And I actually want to grow my business slightly only because I like working with other people. So
Uh-huh.
that's my thing. Some people
Yeah.
definitely like working alone, and that's totally cool, but that's not me. So,
Yeah.
but yeah, but yeah,
But
if you,
that's the thing, that's you. And then, I mean, it's not that I don't like to work with people. And if I had the right environment, maybe I'd do it again. But it was just a clashing of personalities, and it was being done all for the wrong reasons.
yeah, yeah,
I wasn't doing it because I thought it would be the right thing. I was doing it because,
that's what, yeah.
that's what everybody was doing, right?
Well, I mean, that narrative's still out there, right? Everybody talks about growing your business, and
Hmm.
yeah, and
So,
yeah, I think we're both testaments to that. You could do it yourself and still make a pretty good living and do
yeah.
it. And yeah, it's definitely hard by yourself, but there
Yeah,
is freedom in it
I
too.
don't get,
You're like in control. You make all the choices.
yeah,
You don't have to
but I
consider
don't,
other people. It's mostly just whatever you want to do. So that is a good side of it.
hmm hmm and, and I'm not always working by myself, so to speak. I mean, because I'm working with
Yeah.
people at the customer site, I'm usually interfacing with two or three different people. People are doing the hardware, other people are, testing stuff out. So I have a fair amount of interaction with other people. It's just not, I don't have I don't have subordinates.
Yeah.
I don't have to be the boss of anybody.
Well, that actually brings up an interesting question that I should have asked earlier, and that is when you're doing projects, is it like they throw stuff over the wall to you, or is it more like, I think what you're saying is it's more like collaborative?
Um, Again, project to project, but the majority of my projects, I'll go out, talk to them about what they want. Um, I may have to interact with the people basically doing the hardware if there's fixturing and that kind of thing, and collaborate to decide what's going to be the best way to do it. Then I'll come back, write up a quote, then write up the code as far as I can get. 9 times out of 10, though, I'm gonna have to go back on site or do it remotely to actually interface with the hardware. And at that point, again, I'm interfacing with the people that are there in terms of what's the wiring got to be. Okay, we've got these devices. Let's try and test them. Are they working correctly or not? So that's where that sort of interface with the other clients comes in.
So when you're interfacing with the other clients, is it typically people who are not LabVIEW programmers, or do you do interfacing with like where they have a LabVIEW programmer and you're just like assisting them, or
Most of my jobs, I'm doing all the LabVIEW coding, and so the interfacing I'm dealing with are with people that have they have the specs on what the stuff needs to do, and they're testing to make sure it does that, and or they have the hardware, and we're working with the hardware to try and get it to work, because 9 times out of 10, even though I've met the specs or the software's doing what it's supposed to be doing, there'll be something wrong with the hardware that will have to be taken into account. It could be something like we have an actuator, but the actuator takes a period of time. How long does it take for the actuator to actually finish actuating, so to speak? Into timers and things like that. When you're dealing with the physical world, all of those things
yeah.
need to be taken into consideration.
Yeah, I think that's like the what verification versus validation. Like they came to you with the
Mhm.
specs, you designed the right things to the specs, but the specs
Mhm.
weren't right or something, or
Right.
was missing from the specs.
Or they forgot some key thing. Like, for example, just like an actuator, like they said, well, then you actuate the actuator and then you take a reading, but all the details of, well, how long do you wait? Is there a settling time? All these details until you physically get in with the instrument, you're not going to know.
Yeah, yeah. No. Very good. Well, it's been a
Yeah.
great conversation, Katya. Thank you.
Yeah. Thank you.
That's it for today's episode of the LabVIEW Experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram at the LV Experiment.